Right, so in the previous videos, we were discussing logistic regression, right? And at the end of last video, we said logistic regression works very well for binary situations. But sometimes we want to classify our our observations into multiple classes. So three or more classes. And we said we are going to discuss something called linear discriminant. So linear discriminant analysis. And I'll usually write LDA because that's a long way to keep writing every time. So LDA, right? I'm going to do LDA. And I'd rather put the warning up front. We are going to write some mathematical equations in this section for LDAs. We're going to write some mathematical equations that will look scary or nasty, but we're not really going to get deep into them. We're not going to get deep into them. I'll put some of the explanations in the bonus section, right? But we're going to derive some things. But let's discuss LDAs. So logistic regression, if you remember well, logistic regression was actually calculating the probabilities directly, right? It was calculating the probabilities directly, if you remember well. Logistic regression was doing this. What is the probability of y being the kth class given that my x is equal to this observation that I've seen, right? And then it would calculate your probability directly like that. It will be like, oh, okay, based on your observations and the betas that I have, the probability is equal to 0.528. It would calculate the probability directly, right? And it would use the logistic function to do this for those two cases, right? In statistics, if we are going to use statistics jargon, this is called modeling. Let me see. Let me write it nicely. This is called modeling the conditional probability, conditional distribution of y given predictors x. So this is modeling conditional distribution. So the distribution of y given my x. Basically, we are modeling it directly. We are modeling the probability directly. That's what we did in logistic regression. But when it comes to LDA, we model the distribution. Let me write it. LDA, it models distribution of predictors, our predictors x separately. So separately in each of the response classes. So it means we are given the classes, and then we model the distribution of the x's in each of those classes. Right? Here we are modeling the conditional distribution of y. Right? Yeah, remember we're saying for yes the probability is equal to whatever it was, and then for the class no, the probability is this. But here we are modeling the distribution of the x's in each of the response classes, right? In each of the response classes, and then we use something called the Bayes. I think it's the Bayes. Let me look at my notes again. I don't know. I don't think it's called the Bayes. I think it's called the Bayes. I'm just going to look at my notes quickly because I was writing it. Yeah, it's the Bayes. We are going to not Bayes. It's going to be the Bayes without the R. The Bayes classifier. That's how I would pronounce it anyway. Bayes. I don't know if that is the correct pronunciation. I'll just call it Bayes classifier. We're going to use the Bayes. Not the Bayes class, the Bayes theorem. We're going to use the Bayes theorem to flip around these probabilities. or the estimates. Let me write the estimates. The estimates for probability of y equal to k given my observation. Cool. We'll see what this means. But basically, we are not directly modeling the probability of a class. We are not doing it directly, right? That is what LDA does. So now, our biggest assumption that we are going to use in this section, our biggest assumption is going to be that the probabilities are normally distributed. We are going to write a very nasty formula in the upcoming videos, but we wanted to emphasize this difference. The difference between logistic and linear regression is logistic regression models this probability directly, but for LDA it tries to go around and then flips whatever we do to get the estimation for the probability. That's what it does, and we're going to see how it does that. In the next video, we're going to use the ultimate classifier. Like, this is the best classifier in the whole world. I would say, from my experience anyway, it is the true classifier, right? So that is our benchmark, the best of the best, right? This Bayes, the one that uses this Bayes theorem. So we're going to do the Bayes classifier. We're going to see how the best of the best classify, right? When we see how the best of the best classify, we're going to see how LDA tries to use this Bayes to at least classify. So in the next video, we're going to do the best of the best, and then we'll take it from there.